Hey everyone, here's the continue notes for 3-4. So what we're going to do is talk about the remainder theorem. So we're still going to use synthetic division that kind of talks to us about that. So it says if p of x is divided by x minus a, so p of x is the first polynomial. So let's say if we go back to here, right, this would be p of x, okay? So if p of x is divided by x minus a, so once again, if we go back, our x minus a is x minus 3. So we have these two polynomials and we're dividing. Then what it says, then p of a is equal to the remainder, okay? So what this means is that, well, remember that we solved for a, we said x minus a equal to 0, right, to do our synthetic division. And that meant x equals a. What this means is if we take a and we plug it into our polynomial, and a is going to be a value, so take a and plug into the polynomial, then what's going to happen, and for every place we see x or whatever the variable they use, then basically that will give us the remainder. So what that meant is, like, let's say I took the number 3 and plugged it into this into this polynomial. So for every place I have 3, so I would have like 2 times 3x cubed, then minus 7 times 3 squared, and then minus 4. It would give us our remainder of negative 13. Let's check that actually. That might be a good idea. So on this example, when we use synthetic division, our a value was 3. So I'm going to take the 3 and plug it for every place I see x here. So I have 2, don't forget your parentheses, 3, and it was cubed, so you got to use your caret key. Then we have negative 7. So minus, don't use a negative because it's going to say you're multiplying by a negative 7 instead of subtracting. So be careful with that. And then squared. And then minus 4. So all I was doing is taking this x equals 3. I'm taking the 3, and every place I see x, I'm plugging it in there. Okay, that's all I'm doing for right now. So plugging in. So when we used our long or synthetic division, excuse me, notice that we got negative 13 as a remainder. So basically what that remainder theorem is saying is if I take our value, plug it into the polynomial, then I should get our remainder. Notice we get negative 13. That's our remainder there. Okay. So how can we get this remainder? Well, there's two ways. You just learned how to use synthetic division, so we can do that. Then we're going to talk about using the direct substitution way, which we just did in that example I showed you. So let's use the synthetic division. So remember how we do that. How do we determine the value of a? Well, we're going to take our x minus 5, and we're going to set it equal to 0. That gives us our a value. So we get x equals negative 5. So really our a, okay, so p of a, our a is negative 5. So now, synthetic division way, remember we're going to take negative 5. That's going to be on the outside of the box. And then the coefficients of our p of x, that polynomial, that's going to be on the inside. So once again, we start with an x cubed. We want the coefficients or the numbers in front of the variables. So we have a 1. Then we should have an x squared term, which we do. So that coefficient is 10. Then our next term should be x, which is 29. And then our last term should be a constant, 24. So we did not have any missing terms, so we did not need to use 0 as a placeholder. So remember how we use synthetic division. I'm going to take this 1, I bring it down below the box. Any values that are below the box, I'm going to multiply by the number that's on the outside. So I do negative 5 times 1. So that gives me negative 5. But remember, we're doing vertical addition. So I do 10 plus a negative 5. So that gives me 5. Then I do negative 5 times positive 5. That gives me negative 25. But we added, so plus a negative 25. That gives me 4 when I do that vertical addition. And then negative 5 times 4, that gives me negative 20. So I have a plus negative 20. I combine that with 24. That gives me 4. So this last number that we get, that is our remainder. And so what that means is that if I took this negative 5 and plugged it into our p of x polynomial, I would get 4 as my answer. Okay, so we have p of 5, or p of negative 5, excuse me, that is equal to 4. But let's once again use direct substitution, okay? Now, when we do direct substitution, you still have to take your divisor, so this x minus a, okay? So you're still going to have to take that and set it equal to 0 to get that a value, okay? So when we do this, once again, so we have p of negative 5, and so what I'm going to do is take this negative 5, and for every place I see x, I'm going to plug that negative 5 into there. So I have negative 5 cubed, then plus 10 times negative 5 squared, then plus 29 times negative 5, and then plus 24. So let's plug this into our calculator here. So I use my parentheses. So I have parentheses, negative 5. And remember, use the caret key for the cubed. Okay. Then plus 10. And then negative 5 squared. Okay. Then plus 29. Parentheses, negative 5. And then plus 24. So we should get 4 as our answer. So we get as our answer 4. Now you may be wondering, well, what does this really mean? Well, negative 5 is the x value. This 4 that we're getting as a remainder, that's actually our y value. So this would actually be a point that is on our polynomial. So negative 5, positive 4 is a point that is on our polynomial. So we can actually use synthetic division to find y values of certain x values for polynomials. Okay, so it's just a different way of thinking. And this will kind of get us into another idea we'll talk about later on. Okay, let's keep applying this remainder theorem to a couple of our problems. So it says the population of tortoises on an island is modeled by the following function. So p of x equals negative x cubed plus 6x squared plus 12x plus 325, where x is the number of years since 2015. That's going to come into hand right there. X is the number of years since 2015. We're going to use the remainder theorem, so what you just learned previously, to estimate the population in 2023. Okay, so when we do this, as stated, x is the number of years since 2015. So notice they don't give us the x minus a. Instead, we have to find what that a value is. To get that a value, we're going to take 2023, and we're determining, well, how far is that from 2015? Okay, because x is the number of years since 2015. That is 8. So our x value here is 8. Now, using the remainder theorem, you really can use either synthetic division or you can use direct substitution. It's kind of up to you. But I want to keep us practicing synthetic division so we get really good with that. So I'm going to use 8. That's my remainder. So 8 is going to be on the outside. And then remember, now I'm going to use the coefficients from my p of x polynomial. So starting with my x cubed, that is negative 1. Then I go to the next one, x squared, that is a positive 6. Then the next one is a x term, we do 12. And then lastly is 325, our constant. So once again, we did not have any missing terms, so we did not need to use a placeholder or use 0 as a placeholder. Now, I take my negative 1 below, okay? That first term, you always take it below. And now every number below this box, we're going to multiply by 8. So I do 8 times negative 1, and then I do vertical addition. So that's plus a negative 8. So now I do 6 plus a negative 8. That gives me negative 2. So 8 There we go. 8 times -2 is a -16. So I do 12 plus a -16. That will give me -4. And then 8 times -4, that gives me a -32. So plus a -32. And this one you may need to just plug into your calculator. So then we do 325 and then plus a -32, that's 293. So this is our remainder. So basically what this is saying is that the estimated population of in 2000, well, of really tortoises in 2003, or sorry, not, yeah, in 2023 is 293. So that would be your answer there. Okay. And once again, you can use direct substitution and it will get you the same answer. Okay, so now what I would like you guys to do is pause the video and go ahead and try example number 2. Okay, here's the answer to number 2. Okay, so here says a technology company uses the function r of x equals -x cubed plus 12x squared plus 6x plus 80 to model expected annual revenue that is in thousands of dollars, okay, for a new product where x is the number of years after the product release. So we're going to use the remainder theorem to estimate the revenue in year 5. So year 5, that's just x equals 5. So we didn't need to do any subtraction or anything. It's just 5. So that is the number that's going to go outside the box. Now I use the coefficients from the polynomial to do my synthetic division. So I have -1 starting with the x cubed, 12 with the x squared, 6 with the x, and then 80, which is our constant. Once again, we do not have any missing terms, so we don't need to use zeros as a placeholder. I bring down the -1 first. So all the numbers that are in black or below the box, we will multiply by 5. So then I get these values here. Now remember, the last number that we get, that is our remainder, okay? So the number that we get here is 285. Now, it would not be $285. Notice I didn't do that. The reason being is that it says to model expected annual revenue in thousands of dollars, okay? So we basically had to kind of multiply here for our thousand. So we had to do 285 times 1,000, and that would be our answer. So really our answer is 285,000. And then you could have used also direct substitution if you wanted to use that to get your answer here. Okay, make sure you guys work on the homework assignments, and if you have any questions, let me know.